let's solve some exponential equations and logarithmic equations. Part A is an exponential equation, so what we want to do is apply ln to both sides. Ln e to the 40x equals ln of 1. Logarithm x and the exponential is the inverse function of each other, so they cancel each other out, and what's left is 40x. 40x equals ln of 1 is 0. So now we get just a normal equation, 40x equals 0. We divide by 40 on both sides, we get x equals 0 over 40, which is 0, and that's the final answer. For the next problem, we have a logarithmic equation. So what we'll do is collect all the different logarithms and write it as a single logarithm, and then apply the exponential function. So to collect all the logarithms, we'll bring this constant 2 inside the logarithm. So I'll have log base 2 of x squared minus log base 2 of x to the power of 1/2, because that's the square root, equals 3. Next, I'll have log base 2 of x squared over x to the 1/2. I have x to the 1/2 in the denominator because I have a minus sign. I have a difference of logarithms, equals 3, which becomes log base 2 of, I'll simplify this somewhat, so I'll have x to the power 2 minus 1/2, which is x to the power 3/2 equals 3. I'll take 2 raised to the log base 2 of left hand side, and that must be 2 raised to the right hand side. The reason why I did this was that 2 raised to a power of log base 2 cancel each other out because they are inverse functions of each other, and I have x to the 3/2 equals 2 to the third, which is 8. I can take cube roots of both sides, so I'll have cube root of x to the 3 over 2 equals cube root of 8. Because it's an odd root, I don't have to do plus or minus. And now I'll have x to the 1/2 equals cube root of 8 is 2. And then I square both sides of the equation, and I have x equals 2 squared, which is 4. This is the final answer. Because in the process of solving this I squared, it's a good idea to actually plug in x equals 4 in the original equation to see that this is actually a solution. But it is. Next problem is an exponential problem, so what we do is apply ln to both sides. So ln of 2 raised to 1/2 x equals ln of 10. The exponent comes out of the logarithm, so this becomes 1/2 x times ln 2 equals ln 10. So now we have, this is a constant, this is a constant, ln of 2 is a constant, so we'll divide by this constant in order to obtain the solution for this, which is ln 10 divided by ln 2 divided by 2, which as a double fraction is ln 10 over 1 times the reciprocal of the denominator, which is 2 over ln 2. So this is 2 ln 10 divided by ln 2, and if you wish you can plug this in the calculator or leave it as it is. It cannot be more accurate than as an expression like this. Part D is a logarithmic equation. It's already in the form log equals to something, so what we'll do is we'll do 3 to the left hand side, so 3 log base 3 of 2x minus 1 equals 3 raised to the 5th power. 3 and log 3 go away, so I have 2x minus 1 equals 3 to the 5th power. So this is 9 times 9 times 3, that is 243. And then I have a simple linear equation which I solve. So x is equal to, this is 243, okay. 243 plus 1, 244 divided by 2. and that's 122 if I didn't make an arithmetical mistake. The next problem is really the easiest one. What we do is just do 2 raised to the log base 2 of x equals, that's 2 to the left hand side equals 2 to the right hand side, so 2 to the 10. 2 and log base 2 go away, and we just have x equals 2 to the 10, 1024.